All right, so here we go with some matrix algebra, and we're doing 7-2 day 2 for pre-calculus. All right, so the first thing, and these actually exist in algebra, but we do have an additive identity, which means that if you take any matrix and add this additive identity, you're going to end up getting that same matrix back out. We also have a multiplicative identity, and the idea is that you would take that matrix and multiply by this form of 1, if you will, identity matrix, and it's going to equal back to the matrix. So again, in algebra, anytime that you add 0 to anything, you're going to get back to that thing. Anytime in algebra that you multiply by 1, you're going to get back to that same thing. So that happens to actually be called the multiplicative identity and the additive identity in algebra, but we just don't usually call them that. So then we have our additive inverse, and so it turns out that there is a set of matrices that if you add them, you actually get this identity matrix. And then your multiplicative inverse also does the same thing. So now instead of adding them, you'd multiply them, and you'd get back to this identity matrix. B here is actually what we would call A inverse. You have to take A inverse of A in order to be multiplying here, but we'll kind of go over those pieces in a bit. So to get your multiplicative identity, it's an n by n matrix, and so that's why we call it I sub n, because it's going to have the same columns and rows, and they have ones along the main diagonal, upper left to the lower right. So it's always going to be over here is going to be your ones, and everything else is 0. It only works for square matrices, so you cannot, for instance, find an inverse here of a non-square matrix, so got to watch out for that. So we've got 2 by 2s, 3 by 3s. Here's our examples of that diagonal that has 1. All right, so we're going to go ahead and multiply matrix A by the identity matrix. All right. So we are going to do A times the identity matrix, which is a capital I. It's just kind of hard to tell. And so in order to do that, we're going to come up with a 3 by 3. And so we're going to take this first row and multiply by this column here. So negative 2 times 1 plus 3 times 0 plus 1 times 0. So that's going to be our first value. Then we're going to take this row and multiply by the next column. So we'll have negative 2 times 0, add that to 3 times 1, and add that to 1 times 0. All right, and then the last one is taking that same row, but now by this last column. So negative 2 times 0, 3 times 0, and 1 times 1. So hopefully you kind of notice that when you have this identity matrix, basically everything is being multiplied and only will end up with one digit. For instance, taking a look at this, that's 0, this is 0, and so really it just matters what that first term was. Same thing here, this is 0, and so it ends up just being that middle term. And then again, this one is 0, this one is 0, and so you end up with the last term. So hopefully you can see that basically you end up with that same row again. And again, when you multiply to get your identity, by your identity matrix, you're multiplying by basically 1. And so in that case, you're going to get back to this A matrix anyway. But of course, we will do the steps to double check. So this next one is going to be this row times this column. So 0 times 1 plus 7 times 1. Sorry, 0. Wait, where am I? 0. Plus negative 3 times 0. And then we'll do that same row, but this next column. So 0 times 0 plus 7 times 1 plus negative 3 times 0. And then the last piece is going to be this same row. So 0, but now times this column times 0 plus 7 times 0 plus negative 3 times 1. And again, this becomes 0, this becomes 0, and this becomes 0, which is lovely because it was supposed to be a 0 anyway to be first. This one will cancel here and leave us with a 7, and this cancels here and leaves us with a -3 again, which is what the identity matrix has, or sorry, the original matrix has. So then we're going to do this last one, the row here, times each of these columns. So 11 times 1 plus 5 times 0 plus -2 times 0. And then we have 11 times 0 plus 5 times 1 plus -2 times 0. And then the last piece, 11 times 0 for this last column, plus 5 times 0 plus -2 times 1. So again, our first row here is going to be -2, 3, and 1. Our next row is going to have 0, 7, -3. And our last row here is 0 and 0, but 11, 0 and 0 and 5, and 0 and 0 and -2. And again, these are the same. And so basically, anytime that you take this identity matrix and multiply it by a matrix, you should in fact get back to that matrix. So hey, there you go. All right, so then the next thing that we're going to need is something called a determinant. And it is used to tell if a square matrix has an inverse or not, because the only way that you can solve an equation is by multiplying by an inverse. And so if you can't have an inverse, then you can't solve an equation. So if the determinant equals 0, then there's no inverse matrix. And so for a 2 by 2 by hand, what you would do is take the A value, which would be your upper left, times the D value, and then subtract the B value times the C value. And that's going to be your determinant of matrix A. The determinant of a 3 by 3 matrix starts to get a little bit more confusing, but technically you're going to be multiplying this diagonal, AEI, times, oh, this is missing. What you would do is rewrite each of these pieces. So you can't really see it here, but I would rewrite ADG and BEH. And so it would be BFG is right here, and then EDH, which is right here. Oh, sorry, CDH. And then again, the other diagonals are GEC, HFA, and IBD, or DB. And of course, that's written down here. So this was just a thing that was supposed to be able to move out of the way, but clearly it's on paper. So, all right. In order to notate the determinant, we do actually put a set of parentheses around it. So in that case, this is not saying absolute value of A. This is saying the determinant of A. And then we would actually write it with these straight lines versus with the little kind of indents on the end. So again, a 2 by 2 matrix we would be able to do by hand. A 3 by 3 would be with a calculator. However, you can do it by hand. You can do a 4 by 4 by hand, but it gets insane. So instead, we are going to, in fact, learn how to do it on a calculator. So first thing that we are going to do is find the determinant. So we're going to find the determinant of B in this case. So determinant of B, remember, just means the symbol of your absolute values with B inside of it. And so in order to get that, we would take our first pieces of AD and multiply those and subtract BC. So this is going to be our A, B, C, and D. And the idea is to take your AD and subtract the BC product. So AD is 2 times 7. BC is -3 times 4. And so we're going to end up with 14. And then plus, because of the 2 minus, or 2 negatives there. And so we get 26 as your determinant. And remember that the whole idea of a determinant is that if it equals 0, then there is no inverse. So because it doesn't equal 0, matrix B has an inverse. All right. So then over here in our matrix of 3 by 3, we're going to get our determinant of A. However, we are going to, as the directions said here, use a calculator, because this process of multiplying each of these is going to get pretty intense. So we are going to go into how to do all of this with a calculator. So the first thing that you're going to want to do, other than turn on your calculator, is to go into your matrix here. So notice that in yellow, we have second to get up there, matrix. And so now we have all of these options of matrices that we could put in. Generally, we'll probably only ever use about 2 or 3 of these. So usually you just keep everything as A, B, and C. In order to do some math operations with these, you can bring them to your home screen by just pressing enter. So if I wanted to do something with matrix E, for instance, I would just select it and now it's on my home screen. And then I could multiply by 6 or something if I wanted to. All right. So again, going to second and then up here to the x negative 1, we also have some math operations, and that's kind of what we're going to be dealing with here. So notice it says determinant, okay? And so in that case, we can do that. We'll learn a few more of these, but the first one here is determinant. So that is what we're going to want to do, because we want the determinant of this matrix. So we can't just say determinant of A and hope that they understand what we're talking about, because we have to actually insert A. So before we can do this, you have to go back to your matrix and go to edit. The interesting part about this is that if you go down to like E and then go over to edit, it pops back up to A again. So sometimes you think you're in a different matrix, but you're in A. So anyway, so just always know that go to edit first and then down to whichever matrix you want. And so since we are talking about matrix A in our operation here, we then go here and we're going to identify how many rows and columns there are. So this is initially the notation for a 1 by 1 matrix, but of course we have a 3 by 3. So we type in 3 and 3, and then once you're done, you press enter, and now you hop down into this area to put in all your data. So again, that was second matrix and all the way over to edit for A. So now we're going to put in all of these digits. So to match up with this one, we're going to put in a 1. And as it goes across. So that's our 1. And then we have 2. And then 7 would be put in. Then negative 2 and 3 and 0. And then 2 and 1 and 2. So now looking at your matrix setup here, we have a matching matrix as what was given as our A. And so now if we go back to the home screen, remember we already typed in determinant of A, and so now we can press enter and it does all of the multiplying and adding and subtracting for us. So via our calculator here, it equals negative 42, and again we did it through the calculator. So just a few notes on how to get to your calculator. Remember that you're going to have to go to second, and then you're going to x to the negative 1. But of course that says matrix. And then the first column is going to be your operations. So it's going to allow, it's basically the variables to take to the home screen. The second column, and of course that's why it's called this, is your math or your operations. And then that third column is where you input your data. So again, this one is the edit, and this one is the math, and then this one is just called names. All right, so that's how you get there for those. Alrighty. And then I guess just to check, we could type this one in and we'd get 26, but no thanks. All right, so let's see. So this is your inverse of a 2 by 2 matrix. So it, I believe that, yeah, you can actually do that on here as well under, I believe it's this one here with the little t. But rather than skipping, the idea is that you're going to take 1 over your determinant and then multiply, because that's going to become a scalar, multiply every single piece of that original matrix by this, and also flipping D and A, and then notice that they've made B and C negative. So the inverse is defined, so able to be found, provided that the determinant of A is not 0. And so in our last one, we did determine that it was 26, 26, and so we can find an inverse matrix of that guy. And so again, to get your inverse, you have to do each of these things. Find 1 over the determinant, flip your A and D, or whatever those 2 corner values are, make the other 2 corner values opposite signs of what they are, and then actually distribute this value into here. And again, why would you want an inverse? And that's because, for instance, if we have 2x equals 5, remember that the idea is that you would do the inverse operation. So rather than 2 times x, we're dividing by 2. And so this is your inverse operation. But of course, now we have an inverse matrix. And so that's going to allow us to then solve for our variable. So that's what we're going to be doing here. All right. So we're going to find the multiplicative inverse, or just the inverse of each matrix, in this case a 2 by 2. So I've put here the formula that we're going to have to use. So remember that in order to do this, we're going to get our determinant value, so A times D minus B times C. So just to help ourselves out, I'm going to put an A here, a B, a C, and a D. And so this is actually B inverse, because we're talking about matrix B. And so I'm going to take 1 over A times D, which in this case is 2 times 7, which we already did, and then negative B times C. So remember that was negative 3 times 4. This is the previous one that we had done. Then we're going to multiply that by this new idea of flipping the D and the A. So now our 7 is up here and our 2 is down here. And then making the other 2 corners negatives. So we'll keep the negative 3 up here, but we're going to make it positive 3. And then we'll keep the 4 down here, but we're going to make it negative. So that means that our inverse equation, or our inverse matrix, is going to be 1 over 26, as we had in the previous example. And then that is going to be multiplied by each of these pieces. So it's kind of ugly, but it's an inverse, kind of like over in our example here that I did. It's not always pleasant. 5 halves, for instance, is not always going to be a nice whole number. So 7 over 26 is what's going to be in our first top left. 3 over 26 goes in our top right. Negative 4 over 26 is going to be in the bottom left. And then 2 over 26 is in the bottom right. And depending on where you're checking your answers for this, it will, the textbook for sure will give you reduced values of these, but we'll keep them as fractions. So 7 over 26 is going to be that upper left. 3 over 26 will also just stay as that, but these will be reduced. So instead of 4/26, you'll have 2/13 with a negative. And then over here, instead of 2/26, you'll have 1/13. So this is going to be that ultimate multiplicative inverse. So again, if I multiplied this, which is B inverse, by this B, I would get the identity matrix. So B times B inverse equals your identity matrix. Which, remember, is ones along your top left to bottom right, and then zeros, everything else. All right, so this next one, we're going to find our multiplicative inverse of this 3 by 3. And so remember that in order to do that, we're going to use our calculator. So let's see. First thing we're going to want to do is go to second and then that x to the negative 1. And we are using an a again, so we may as well, since we already edited it with our previous example, and that's what they're redoing here, we can go ahead and use that. So there's two ways that we could go about doing this, and actually the most simple way is to say that we are going to find a and then this little inverse symbol, because that is how you identify inverse. So if you remember back to algebra, we said that there might be an f of x equation, but then there's also an f inverse of x equation, which had a little 1 there, okay? And so in that case, that's what we're having here, is just an a with a little 1, and so in that case, it would give us that inverse matrix, which is what we just found in this one. And so what it's going to do is give you the 1 over the determinant, but then it's also going to do some kind of this funky stuff with the other equation, which we didn't write down because we're having our calculator do it. So if you press a inverse to the negative 1 and then enter on your home screen, notice that you actually get all of these values. And of course, since we didn't do it by hand, it's not going to give it to you in fractions, but of course, some of these fractions we can determine what they are. So we're going to just abbreviate each of these. And of course, if it was the middle of a problem, we would want to have as many decimal places as possible. But in this first one here, we have negative 0.14. And then this second row, we have negative 0.10. If you round a 9 up, it's going to be 10. And then 0.19 for that first column. Then scrolling over, our second column starts with a negative 0.07. Then we get double checking it's not negative, 0.29. And then the last one is going to be negative 0.07. All right, and then our last piece, these are actually some fractions that we know. So for instance, 0.5 could have been 1/2. 0.3 repeating could have been 1/3. And then 0.16 repeating, we're just going to put that 0.16 because I can't remember what that is. All right. So that is our inverse matrix. And so again, if we multiplied these two, we'd get back to that diagonal of a bunch of 1s matrix, the identity. All right. So this next one here, we're going to verify that these matrices are inverses. And so remember that the idea of verifying if something was a matrix would be able to multiply them and hopefully get the identity matrix. The reason that this is a 2 by 2 is because it's a whole lot easier to do it that way. So we're going to by hand multiply these, and then I'm going to show you quick how to do it on the calculator. So the first thing here is going to take this row by each of these columns. So again, we're trying to see if we get the identity matrix. So hopefully A times B is going to equal the identity matrix, which is going to be 1s on the diagonal and 0s. So in order to get that, I'm going to take this first row, so 3 times this first column, 1, and that's going to be added to 1 times negative 2. The next piece will be 3 times negative 0.5, and that's going to be added to 1 times 1.5. And then we'll have 4 and 2, which will multiply by this column. So 4 times 1 plus 2 times negative 2. And then the last one is going to be 4 times negative 0.5 plus 2 times our last digit over here, 1.5. So hopefully, again, these are 0 once you add them, and then these are going to be 1s. So 3 plus negative 2, or 3 minus 2, does in fact get you a 1 in your result. Over here, we're going to have 1.5 with a negative for this guy, plus 1.5. And so, of course, that's a 0. Down here is going to be 4 minus 4. That's a fancy 4. Okay. And then over here, we're going to have negative 2 plus 2 times 1.5 is 3. And so that's 1. And that would be 0. And so because it ends up being the identity matrix, we do in fact have A and B are inverses. All right, so kind of verified it there, but remember that we can also do this with a calculator. So 2 ways we can do that. One of them is to go to your matrix and edit your matrix A to look like this and your matrix B to look like that. So if we edit matrix A to be a 2 by 2, I'm going to plug in 3, 1, 4, and 2. So we have 3, 1, 4, and 2 in your 2 by 2 matrix. All right, then going to matrix B, again going over to edit and then down to B. We have another 2 by 2 matrix. And so I'm going to put in 1 and negative 0.5. 1 and negative 0.5, and then negative 2 and 1.5. So those are the other two pieces. So now I have both of them in there. And so we will go back to the home screen, second quit. And now I can do the operation of A times B, which means that I go to matrix and get my name of A, and then the multiplication sign, and then the name of down to B. And so A times B, as we did here, should end up with a 1, 1, and a 0, 0. All right. The other way that we could have done this is by taking the A matrix and doing the inverse of it. Because if we multiplied this by this and got the inverse matrix, or this identity matrix, then we would have had A inverse, which would have been here. So A inverse, hopefully, is 1, negative 5, negative 2, 1.5. So that's 2 different ways other than by hand that you could have checked that worked. All right. So each of those techniques and ideas is going to be on our assignment. So your assignment is 7-2 day 2, page 590, number 29 through 43. All right.